So this is part 2 for the Algebra 2 Common Core Regents review. So now we will look at example 11 here. So now notice the following. It says that the solution to the equation 18x squared minus 24x plus 87 equals to 0. What is the solution of this equation? Well, one thing that I do notice before we even start looking for a solution is that there is a number that can fit into 18, 24, and 87, and that is 3. So what I'm trying to say here is that before we start on analysis, we can factor out 3. Let's make our problem even easier. So if we factor out 3, we will have the following. If we factor out 3, then we have 6x squared minus 8x plus 29 equal to 0. Why did we factor it out? Because now if we divide it by 3, this cancels out. And now we have 6x squared minus 8x plus 29 equal to 0. So at least we reduce the numbers. I'm sorry, this is not 29, but this is 29. Yes, so it is 29. Okay, good, perfect. So now that we know that we can rewrite it in this way, let's look at the options here. We have option 1 through 4. They all talk about plus or minus, and they all have square roots, and they all have complex numbers here. Because we have that, that's kind of an indicator that we have to use the quadratic formula. Where if you remember from your previous class, maybe Algebra 1, the quadratic formula looks something like this. X equals minus b plus or minus b squared minus 4ac all over 2a. Perfect. So if we look at our new formula here, or at least our more simplified expression, we can see that our a is 6, we can see that our b is negative 8, and we can see that the c is 29. All right, so let's plug it into our formula here. So now if we plug it in, we're going to have negative b, which we found it to be negative 8, plus or minus b squared, so that's going to be negative 8 squared, minus 4 times a, which we found it to be 6, times c, which we found it to be 29, all over 2 times a, where a is 6. Now here, you can find this all in the calculator here. And if we find this in the calculator, you will have the following. Well, negative times negative 8, that's just positive 8, plus or minus. You can find negative 8 to the second minus 4, 6 times 29 in your calculator. And if you do so, you're going to obtain the following. Negative 632. And this is going to be all over 2 times 6, which is just 12. Now, look at this right here. We have a negative inside the square root. So that means that we have a complex number. You can never have a negative side of the square root. So what do? Well, let's continue here. We have x equals 8 plus or minus. Let's take it out as an I. So we have the complex number of 632 divided by 12. Now notice the following. Notice that 632, you can rewrite it as, remain the same, 632. We want to rewrite it into a perfect square number, but we know that 632 we can rewrite as 4 times 158. You can check that in your calculator. Now, why do we use 4? Because this, we can rewrite it as the square root of 4 times the square root of 158 over 12. But we do know the square root of 4. The square root of 4 is 2. So we can rewrite this as 8 plus or minus. So now we have 2i's square root of 158. Still, everything with a 12. But now, notice that this 12 is dividing both terms. It's dividing the 8 and the whole 2i square root of 158. So let's just make it more simple for us. Let's just rewrite it this way. But notice that 8 over 12, this is equal to 2/3, plus or minus, and 2 divided by 12, that is equals to 1/6. We have complex I, 158. And now if we look at this, we will see that we do have an option here, because this same expression is the same as option 4 here. Okay, let's look at example 12 now. In example 12, we have the following. It says, when g of x equals 2x, 2 divided by x plus 2, and h of x equals to the log of x plus 3 plus 3, when they are graphed on the same set of axes, which coordinate best approximate the point of intersection? Well, if we want to see the point of intersection, what we should do is graph it. So let's graph the following here. So let's see. Let's look at the first function. Let me graph g of x, which is going to be 2 divided by parenthesis x plus 2. So here we have the first function. So now on the bottom, let's graph the second function, which is going to be the log of x plus 1 plus 3 on the outside. Because again, we want to see what coordinate best approximate their intersection. So we're going to be looking for the intersection. So let's graph it. Okay, so if we graph this, let's look at the following. Maybe we should have done one at a time. So now this is our g of x. It's 2 divided by x plus 2. If we graph this, this is the function of g of x here. Now, if we put on top of it, we put the other function, which is the log of x plus 1 plus 3. Now that is right here. Now, we want to find out the point of intersection. Now, notice that it is about this point right here when they kind of intersect. If we want to have like a more specific answer for this, we can press second, calculate. Let's look at option 5 because we're looking for the intersection. So we can use this option. So now it says, what's the first curve? Well, just try to have a point that is around where you think the intersection, which is somewhere around here. So there it is. What is the second curve? Well, still that point. So the second curve is this one. Do you want me to guess? Yes, please. So now this are our points of intersection. So let's look at our options here. It says when x is negative 92 and y is 1.86. Now, you might guess, well, I mean, right here we can see right away there's not option either 3 or 4 because we know that the x has to be negative 0.9. So now it's down to 1 or 2. But note that this is going to be a little bit tricky here because just by looking at the numbers, you might just choose 1.8 because that's what you see here. But notice it's 1.86. So we got to round up this number. So now this becomes 1.90, which is option 2. So let's just be careful with the rounding up. If we would have not round up, you might have just guessed to be option 1. But because we have 1.86, we got to round it up. So that's 1.9, and that's what we choose, option 2. All right, so let's look at example 13 now. Let me make this a little bit shorter so it all fits. Perfect, right here. So let's look at the following here. It says, the price of a postage stamp in the year since the end of WW1 is shown in the scatter plot. So we have a scatter plot. Perfect. But now what is the question here? It says, the equation that best models the price in cents of a postage stamp based on this data is which of the following? Well, let's see how this function behaves here. So notice that if you kind of connect the points, you're going to have a function that is going to move like this. If you do the line of best fit, it's going to be something along those lines. Look at the options here. Look at option 4 here. 4 talks about a sine function, and a sine function is a periodic function. A sine function should look like a squiggly line here. which obviously it's not. So we can just get this out of the way. So now it's down to 3. Look at option 1 here. This is a linear function right here. This does not look like a line. If we would have drawn it as a linear function, it would have to be a straight line. So option 1, it would be a total straight line, which obviously it's not here. Look at the highest exponent is 1. So that means that this is a linear function. We do not have a linear function here. Obviously, it's not. It's not a straight line. It has some kind of a curvature here. So it's not option 1. So now, which one is it? Option 2 or option 3? Your best guess is to graph them. So let's actually graph them. If you're not sure, let's graph them and let's see which one kind of matches this points. So let's look at option 3 here. So we have 1.43 parentheses 1.04, and we have an exponent of x. Exponent of x. All right, so let's see how that function looks like. Obviously, let's zoom out. So we got option 3. Let's zoom out because it kind of looks like it's a straight line there. Okay. Let's zoom out once more. All right. So you see that it kind of goes like this and it starts shooting up. All right. So this is option 3 right here, which is a pretty good guess. Like notice that it goes straight and then it just shoots up. Let's see what happens when we use option 2. Let's see what do we obtain when we graph option 2 now. So we're going to have 1.04 parentheses 1.43 exponent x. Okay, so let's see now. Okay, well, you can see the difference, right? Like, look at that. This is option 2, and this is option 3. If we compare to what we have here, notice that in option 2, which is this graph right here, it just goes up real fast, which does not happen like this. It kind of like goes straight, and then it just moves up little by little. It doesn't have this big spike here. This line is example 2. This line is option 3. So it's a little bit more clear that the correct option will be option 3. Okay, well now, let's look at the next function here, or the next problem. All right, so now, let's quit this. All right, so let's see. Option 14, it says, the 8th and 10th term of a sequence are 64 and 100, okay? If the sequence is arithmetic or geometric, the 9th term cannot be, so we're looking for false. We're looking for what is it that it cannot be. All right, let's check the easy example first. Let's look at the arithmetic. Okay, because we have arithmetic or geometric, so we got to look at both cases. So let's look at arithmetic first. Now, what do we have here? Well, let's see. We know that the 8th term is 64, so we got 64, then we got the 9th term, and then we got 100. Okay, so again, this is what is it? This is the 8th term, so this has to be the 9th term, and this is the 10th term. Okay, so cool, perfect. So we want to know, well, what is the 9th term here? Well, notice here that if you go from 64 all the way to 100, no, hold on. Let me state it a different way. But notice here that if we have 64, if we add 18, we can see that because it's arithmetic, you need to add or subtract. That is the pattern. The pattern needs to be of addition or subtraction. But notice that if you add 18, you're gonna end up with 82. And if you add 18 again, you're gonna end up with 100. So that means that if it's arithmetic, we identify the pattern to be plus 18, which means that the 9th term is 82. So that means that right here is not option 4. So now let's look at the most, let's look at geometric now. Okay, so on the geometric case, we still have the same, so it's going to be 64. And then we don't know the 9 term, and the term is still the same, which is 100. Now, if it's geometric, we're not looking for addition or subtraction, we're looking for multiplication. So we got to find out a number that if we multiply twice, we're going to go from 64 to 100. So now, let's just take some guesses. Let's say that this is 80. Let's just say. Let's take a guess, because we're looking at the options that are still left. Let's say that this is 80. Okay, good. So that means that there is a number, we just call it x, which we can have the following: 64 times whatever x is should give you 80 because of our guess. Well, let's divide 64. So that means that here x is equal to 5/4. Okay, so let's say that x is equal to 5/4. So we know that 64 times 5/4 is equal to 80. So now let's double check that if we go 80 times 5/4, let's see if that gives us 100 still. So we have 80, and we will multiply that by 5/4. Oh, good. So that's 100. Perfect. Perfect. So that means that yes, here our 9 term is 9. And again, we took a guess. But so we can see that 80, it can be our 9th term. So it cannot be option 2. But also notice that what if we would have multiplied by negative 5/4? Then this would be negative 80 multiplied by negative 5/4 again. So that's 100. So that means that negative 80 can be, and it will be, our second. Notice that negative 80 can be our 9 term as well. So we can cancel this out. So we can see that the only option that is left is option 1. Oops, sorry about that. All right, so let's continue here. If we look at example 15 now, you can read the problem on your own. But now the question here is, in option 15 or question 15, is that we've been given a formula, which the formula is being given right here, which is d is equal to 10 log of I or I naught. And if you read the problem carefully, you will see that I will have a value of 6.3 times 10 minus 3, and you will see that I naught will have a value of 1 times 10 to a negative 12. Everything is right there on the problem here. But what we want to look at is what is the value of d. But notice that d has an equation. We know I and I naught. So all we have to do here is just plug that in. But now I, from our formula, is 6.3. Let me scroll this down. 6.3 times 10 minus 3. And this is going to be divided by 1 times 10 to a negative 12. Now we do this in the calculator, 10 times log of all this. You will see that d is equal to 98. But now let's see here. The question is, how would a sound with intensity, which we already use that as I, be classified? So now notice that here we have that d is equals to 98. But if we look at the different options here, we can see that it can be classified as very loud because 98 is between 90 and 109. So that narrows it down. Question 15. Question 15 is option 3. All right. Well, let's see if question 16. Each own an ant farm. All right, that's cool. Good for them. Now Pedro starts with 100 ants and says his farm is growing at an exponential rate of 50% per month. All right, so this is who's this? Who's Pedro? So Pedro starts with 100 and it will increase 15% every month. So now Bobby, he starts with 350 and he says that he has a steady decrease by 5 ants per month. All right, so let's write down some equations for Pedro and Bobby. So notice that Pedro, it says that it's growing at an exponential rate. So that means that the equation of Pedro should look something like this, which is going to be pretty much your starting point, and we're going to multiply times 1 plus whatever the percentage that we have an increase, or let's just call this the rate, and this is going to be to the x exponent. So let's plug in the information that we know. For Pedro, it says that we start with 100, so and now we're going to have 1 plus the rate, but note that the rate is 15%. If we convert that to decimal form, that's 0.15 to the x. So that means that the equation for Pedro is equals to 100 times 1.15 to the x. All right, so this is Pedro. And we know that this is Pedro because it says it's exponential. And this is pretty much how you write an exponential function. Hold on, there's something going on here. Oh, I wrote an extra one. I'm sorry. It says 1 plus the rate. All right, so that looks more like it. All right, so that is Pedro. But now, let's look at Bobby. But now, Bobby says here that steadily decreasing. So that means that we're not going to have any kind of an exponential. We're going to have just a linear function because it's steadily decreasing. So let's just write that down. For Bobby, we're going to have your starting point, which is 350. And it says here that is decreasing by 5 ants per month. So that's going to be minus 5x, where x represents months. So let's write down here, x is months. Perfect. So now we have an equation for Pedro, we have an equation for Bobby. So now let's see, what are they asking us to write down here? It says, assuming both boys are accurate in describing the population of their ant farms, after how many months will they both have approximately the same number of ants? Now, if you want to know when both have approximately the same number of ants, what you have to do here is just set those equations equal to each other. So we're going to have 350 minus 5x, that is equals to 100, 1.15 of x. Now, if we want to know when are they equal, we pretty much want to find out at what value of x will they be intersecting. And for that, let's just graph it here. So let's come here. Let's graph the first function, which is 350 minus 5x. And the second function is 100, parenthesis, 1.15 exponent x. Okay. Okay. So let me, hold on, let's see. Let me zoom in. Now let's just look at the window. Let the window be negative 10. The maximum will be 10. Let's see what's going on. That's fine, 11. Y min, let's make this negative 10. And Y max, let's make this positive 10. All right. I really have no idea why it's not graphing here. But if you will graph it in your calculator, you will see that they're meeting each other when x is equals to 8. It just, for some reason, the calculator is not working right now. But if you will graph it, you will see that they're going to meet each other when x is equals to 8. Sorry about that. Now let's look at example 17 now, we look at the example 17, it looks complicated, but we gotta really understand what they're asking us to find here. It says, what is the solution, if any, of the equation? Okay, so let's see, how can we make our problem more simple? Well, notice that this denominator, it looks like it can be factored. All right, so let's see. When we have this kind of equations, the easiest way to approach it is make sure that every single denominator has the LCD. So let's just rewrite our function. So we have 2x plus 3. But now here, I don't like this minus. So I'm going to change the sign of the denominator. And this is going to become a plus. So we have plus 3x minus 4. Notice that we changed the sign here. We changed the whole sign. Or we multiply by a -1. We literally just multiply. We change the sign of all the symbols here. Let's go to x minus 2. And like we studied, notice that here, x squared minus x minus 12, this is equal to x plus 3 and x minus 4. I mean, if you were to factor this out, you would see that you can write it this way. So this is a 4. So that means that, well, let's come back to our problem here. So we have x plus 3 and x minus 4. So now notice here that the least common denominator is x plus 3 and x minus 4. Okay, so that means that in our problem, we are going to try to have every single denominator to be written as x plus 3 and x minus 4. But notice that the first fraction here, it already has x plus 3. So all we got to do is just multiply x minus 4 top and bottom, because we want to make sure every single fraction has the same LCD. So now notice that here we have x minus 4. So that means that for this fraction, we're going to multiply x plus 3 top and bottom. We're not going to multiply anything on the right side because it already has x plus 3 and x minus 4. All right, so if we do this correctly, we are going to have 2x minus 4 divided by x plus 3, x plus 4, plus 3. Then we have this fraction here. And notice that on the right side, we didn't do anything, so let's just rewrite it. Okay, perfect. But now, what's the purpose of this? Why do we even bother to write every single denominator the same? Because once every single denominator is the same, you can just cancel them out. And now you can set the numerators equals to each other. But here, let's just do 2 steps at the same time. So now we're going to have 2x minus 8 plus 3x plus 9 equals 2x minus 2. So notice that now this just becomes like a linear equation. Now we got to solve for x. If you combine terms here, you will have 5x. You combine terms here, you will have positive 1 equal to 2x minus 2. Okay, so we're almost done there. So let's see, we want to solve for x, so let's subtract 2. Cancels out. So now we have 3x plus 1 equals to negative 2. Subtract 1. So now we have 3x equals negative 3. So that means that x equals to negative 1, which, if we look at our options, that is option 1. Okay, perfect. Now, if we observe example 18, we have, in 2013, approximately 1.6 million students took the critical reading portion of the SAT. The mean score, the model score, and the standard deviation were calculated with those values respectively. Which interval reflects 95% of the critical reading scores? Now, this 95% here, it should be familiar here, because when it comes to normal distribution, we have a rule. And this rule is called the 68, 95, 99.7 rule, which says if you have a normal distribution, you will have 68% of the normal distribution on your first standard deviation. Now, if you take two standard deviation, you will obtain 95% of the normal distribution. And if you take three standard deviation, you will obtain 99.7. But now notice here that the question is asking you which interval represents 95% of the critical reading scores, which pretty much is asking you what's going on when you take two standard deviation. From where? From the mean. So to find out what is the interval of 95%, what we have to do is we're going to get the mean, and we're going to do plus or minus two standard deviations. And again, R or sigma, it's standard deviation. Well, let's see if we can plug in the information that we have here. Do we know the value of the mean? It says the mean score, the model score, and the standard deviations were calculated to, well, we know that the mean is 496. Plus or minus 2, and the standard deviation, where if we look at the problem, it says that the standard deviation is 115. Okay, so 496 plus or minus, now would you just multiply this, and this gives you 230. Which if we look at the options that we have here, that is option 4. Okay, so let's look at example 19 now. In example 19, it says, which statement regarding the graph of the function below is untrue? Okay, so pretty much we're looking for a false statement. So let's see, f of x. Let's look at the options. Well, we have f of x, g of x, h of x, and j of x. The first statement says f of x and g of x have a minimum of y value of positive 3. So now f of x is right here, and g of x is right here. Notice that here the amplitude is 3, so that means that it does have a maximum at the value of 3. So we know that f of x does have a maximum, a value of 3. If you don't believe me, you can just graph this. You can graph it and you will see it real quick. Let's do this real quick here. Well, let's see if the calculator is working now. So we have 3 sine of 2 of x. So here, yes, I really do not know why it's not graphing correctly here. I'm assuming it has to do something with the windows, but let's see here. Nah, I'm not even going to bother here. But you will see that if you graph f of x and g of x, you will see that they will have a maximum of positive 3. So this is true. This is a true statement. All you got to do to convince yourself is graph it. But sorry that the calculator is not graphing correctly right now. Now, if we look at example 2 or option 2, it says f, h, and g have one y-intercept. If we will graph h of x, you will see that h of x does not have a y-intercept. Well, I mean, let's just hope the calculator works now. All right, let's see. Let's graph h of x so you can convince yourself. H of x, well, yeah, well, I mean, if you look at here, this is base 2, so we got to do the whole conversion form, which is log base 2 of x. You can rewrite it as log of x divided by the log of 2 if you use the change of base formula. So we're going to have log of x divided by the log of 2. And if you graph this, alright, well, this is working. Notice that when we graph this, h of x does not touch the y-intercept. It looks like it touches the y-intercept, but it definitely does not. That's one of the properties of the logarithm. The logarithm can never go either 0 or below 0 because we're talking about log here. That is one of the properties for the logarithm. So that means that this is a false statement because of h of x. H of x, it's a log. The log does not touch the y-intercept. So that makes the whole statement false. Lastly, let's look at example 20 here. It says when g of x is divided by the following, the remainder is 0, and you've been given the following function, which conclusion about g of x is true here? Now, notice here, this is really important here. It says if x plus 4, when we divide it by this, the remainder is 0. We have one important conclusion from our previous classes is that if the remainder is 0, that means that x plus 4 is a factor of whatever we were dividing, which is g of x. But we know that if x plus 4 it's a factor of g of x, then that means that x minus 4 is a solution. Now, if x equals to negative 4, it's a solution. That means that when you plug it into g of x, it should give you 0, which pretty much is saying that g negative 4 is equal to 0. Because this is the property of a solution. Like, if you have a following function, if you plug it in and it gives you 0, then that is a solution. So, with that said, g of negative 4 is equal to 0. So this concludes part 2. In a couple of seconds, part 3 will start.